Today we are going to be learning how to use StarPro to design a full water tank stand. So as we can see from this diagram, this is a water tank of 5 meter by 10 meter, and this water tank has three and six columns with beams and with a slab. It's a concrete tank stand, and the concrete tank stand is having the water tank is of a height of 2 meter, and the length of the water tank is 10 meter. So if you do the mathematics, um, we find how many cubic meter of water this tank can contain, is around, which is about 100 cubic meter of water. And when we convert this cubic meter of water to weight, we'll find out that the tank, the weight of the water on the tank is going to total to 1,203.6 kilonewton. Now, how did we arrive at that? The weight of water is 1,000 kilonewton, and weight of water is 1,000 kilonewton. Weight of empty weight of the empty tank, that's the weight of the tank itself, is 20 kilonewton. The weight of slab is 3.6 kilonewton, and we're supposed to put the weight of beam itself, because what we are trying to design here is a beam, and likewise the column together, but every load is transferred from the beam before it gets to the column. So we're going to use StarPro to analyze this, and we're going to see how it's done. So for us to do that, we click on StarPro. New structure, we're going to use 3 space, because it's going to be a 3 space structure. So I use my design to save the work, then I click on next. I use admin. Now, since I'm going to draw a 3D face object or drawing, so it's right I create my own grid dimension. So I click on dimension, I click me. This time around, we are not going to be talking about XY, but we're going to be talking about XZ, so that whatever we're going to do will now be on the Y direction until we start. So the tank is 5 by 10, So this can be able to contain it. So we are okay with that. So you click OK. You click on this. So this is what we have. You can see the difference between this and the other one we had before. So if we are to draw the our this thing of slab, we have here is 5, we have here, we have here again, here, here, escape, click here 2 times, so that's get this. So at this juncture, this represent the top of this. You can see it. I will be created the plan. So and that is not all. So we are going to produce this structure in three-dimensional form the way it is. So what we're going to do at this moment is we're going to use nodal. Look at where I click nodal cursor. So I'm going to select the nodules. I'm going to select translational repeat. I'm going to select translational repeat. So I want this stuff to move in the global y direction. And let's figure out the height of this is 4.5 meters. 4.5 meters. So the height step is going to be 4.5. So with the link step, okay, you have seen the settings like this. I will now click OK. And you see it. What I have done have been interpreted the way it is. So what I will do now is to connect all these dots with my beam cursor. So I'll click here. I'll connect this to this. Connect this to this. This to that. So I'll remove this. So this is what we have. If you view it in, if you check the front view, is what I'm going to get. If you check the top side view, this is what you're going to get by the side view. So if you go 3D view, this is what you get at this point. So we have one this thing with the input, so this is expanding from here to here. So we have completed the drawing. So now we are going to put support to our tank stand, and we know that the support from foundation is assumed to be fixed or fixed. So click on support and we create, click on fixed support, say add. Now add to I've used cursor to assign, so I'll click here. I'll use cursor to assign, so assign this. So we have successfully assigned our support to this stuff. So now the next thing to do is to give support to our beam, to give support to our beam. So that is what we are going to do now. So we're going to give material to the beam and the column, and since this is a concrete member, so we're going to create a concrete material. So we'll go to property and say we define is a rectangle type. So the first thing we are going to define is let's say our beam is a 0.225 by 0.350 beam. Sorry, this is YD 0.350. Y this is 0.225. So click add. Then the columns, let's say that the columns are 0.250 by 0.250. So this is our column, this is a square column. I'll click OK. So at this point, we need to add these materials to their positions. The first thing we're going to add is a beam. So say add assign. So we assign with cursor. So we assign to cursor. Assign here. Assign here. Assign here. So these are all our beams. We have assigned this material to it. So the next is our column. Using the same method, we assign to the columns. Okay, so assuming you want to see this thing in three-dimensional form, you click on structure diagram, you click on full section and click OK. So look at it. This is our structural diagram. Everything is connected. Look at it. So you can see how it is connected. So you can move it around. You can use this tool to move your structure around. So this is our structure. Now at this point, the next thing to do is to add our load to the structure and do our analysis. So we'll go back to where we're coming from. Go back to structural diagram and click on none so that we go back to what we had before. So now at this point we are to assign load to the beam that we want to design. We want to assign load to the beam that we want to design. So let's go back to our stuff. Um, we have seen that the total load on the structure is 10 1023 1023.6 kilonewton, which is approximately 1024 kilonewton. Now we need to convert this load to a a kind of uniformly distributed load on the structure. If we want to place it here, here, and all of them, so that we know each structure, we know the kind of load um, is going to carry. So at this time around, this is kilonewton. So to convert this our load to meter, so we are going to divide the load 1024 kilonewton by 5 meter, so that we have the value. Let's use a calculator and find out what we have. So we have 1024 divided by 5. So we have 204.8 kilonewton per meter. 224 kilonewton per meter. So that is our load that the structure is going to carry as it spans this way or the other way. So 224 kilonewton per meter. So that's the load the structure is having. So having done that, so we go back to our structure, and since we didn't add the weight of the beam, which is good, the structure will now add it for us here. So that is the concept. So um, so at this point we click on our load. Now we have click on load case. You add. We have load case 1, which is the dead load. Add load case 2, which is a live load. Add. So our dead load is normally the self weight of the structure. So you go up to self weight, you add. So the second one is the dead load, member load, because the UDL, and we got 204 or 205 kilonewton. So have minus 205 kilonewton. So you have minus sign, show it's acting globally downwards. So the load is 5 meter. True. So I've created that. So you add it. So at this point we have to add the load to the structure. So we assign to view. So you click assign to view so that you're going to take everything. So this load, this self weight have been assigned to the whole of this structure. So now we are going to now calculate the imposed load after we create our envelope during our design, load combination. So you click here. We assign this one using our cursor. So we assign using cursor. So we have here, we have here, we have here, we have here. No, but the mistake we did is that all these structures will not carry the same amount of load. So let's go back to our calculation. So since this load is like this, so if you separate this thing into two, this structure is going to carry half. Let's do it by plain way. We know that the way it's supposed to be is that this will go like this, this will go like this, and this will go like this, and we use what we call the flow load to do that. So this is so if we do it in a plain form, so this is 2.5. So we are going to divide this stuff by 2.5. We're going to divide it by 2.5 instead of dividing it by 5. Sorry, we are going to divide it by 2. We divide what will have the load by 2.5 kilonewton meter, because this structure is going to carry half and this is going to carry half. And the same thing, this is 5 meter and this is 5 meter. So it's just the same thing, clicking half of it. So we go back here to this and equals to, sorry, we have 205 all over 2. So each of these being is going to carry 102.5 kilonewton, 102.5 kilonewton. So let's effect a change to edit. So here 105. So change it, close. So let's continue the assigning. So we assign our loads. So we have succeeded in assigning the load to the structure. So at this point in time, once we have finished assigning our loads, I believe the next thing is to go ahead with our design. But before we do that, we would like to bring our dimensions so that we understand what we are doing, and also we are going to bring out our nodules. We're going to bring out our nodules. So I'll click here, go to structural diagram, go to labels, nodule number. Okay. So so these are nodule 1, nodule 2. So let's view it in the other way around. So this is nodule 1, this is nodule, so that we know where we are viewing. This is nodule 8, nodule 9. Although when you analyze the system, when you click on any of them, the system will show you exactly where the nodules lies. So this is our section of the stuff. So we are going to analyze this structure at this moment. So we'll click on analysis and print. I will say or perform analysis. We'll say add. So at this point, we now click on our analyze and zero analysis. So the system has done the analysis, 0 errors, 0 warnings, and these are outputs. So these are outputs. So if you want to see your calculation sheets on everything, so you can print out this stuff. So at this point, we can go to our post processing to see what the structure looks like, the moments and everything. So first of all, we go to our beam. So look at it. Look at your bending moment diagram. Look at how it is very clear. So when you go here, for each and every nodule, if you want to get what this place is, so this is so this is beam 13, and beam 13 has nodule 6 and nodule 12. Nodule 6 and nodule 12. We have this is beam 18, and it has nodule 8 and nodule 7. So nodule 8 and nodule 7. So just like that, you have 9, have nodule 9 and nodule 8. So this is how you can check all the nodules you have and all them, and as well being able to find out what the moment is all about. Here, look at all the moments, you can be able to find them out. So at this point, we are going to run our design. First of all, we are going to run this design based on system design, and after that we now run it based on interactive design. So having said that, so let's view some of other views. So let's go to graph. So this is our bending moment diagrams and all the rest of them. So you want to go to your animations, want to know how this structure will behave in displacements. So this is it. You can see how the structure is moving, how it's vibrating. It's showing you the displacement parts, how it will be displaced under the load. So if you click on deflection to show you the deflection diagram, the deflection is maximum at the center. So that's it. So we have seen it. So the next thing to do is to go back to our work. So we need to do our design at this moment, and it's a concrete design. So we'll go back to modeling. So when you go back to modeling, you click on design, and the system will ask you the type of design you want to do. So we're going for a reinforced concrete design. So if we're going for reinforced concrete design, the system will bring out the code for design of reinforced concrete, and we're using BS 8110 as the code. So if we have selected the code to be BS 8110, we go to command, and say beam and column design, add column design, add. So we've added it. We want to design our beams and columns. So let's define the parameters that we want to use in this design. We should define parameters. So our columns are column brace only one look at the direction, column brace in either direction, column brace in both directions. So column brace in both directions, and clear distance from the surface of the member to edge of member. Reinforcement is 0. At this point, we change some of these our values. So we change to millimeter and we change to Newton, so to be easy for us. So now at this point, we'll go back to define parameters. So this is 0.225. So depth, you add the with default is and maximum length factor is 1. So we use 25 or 30 Newton per millimeter square. But the tank is going to be exposed. Main reinforcement 410. Maximum reinforcement for 20 mm. Minimum reinforcement we go for 12 mm. Section no serviceability check, continuous beam, simply supported beam, and lever beam. So it's a continuous beam, and there will be serviceability checks. It's not simply supported. Not simply supported. So it's a continuous beam. So track. So we design the beam, detail, output, minimum, maximum steel spacing, and column design. So select this. So we've added all our design parameters. So what we do is to add it to the whole structure. So we're going to add with view. So when you click, you see assign view. as you are signing, the question marks are changing from question mark to um, good sign, the green. All of them must be changed to, must be tick good. So we are done. So having done this, we are going to run the analysis once again so that we see our design. So we'll go back to analysis and run the analysis once again. So we are done. So to know whether the system of design is, double click. So you can see our design has been done and the system say provide 2y20 on top and 2y20 below for the supports, and here we provide only 2y, 2y32 at the bottom and also 2y20 at the top. Okay, this is 2y32 on the top. This is where you have 4 because of the support moment. So click here. So you have here so we have 3y32. This one I have here 2y32. So this is column design. This is our column design. So don't be surprised that it sees everything as a beam, but it's a column design. So when you see the value center to center, look at the reinforcements, you can understand what is being done here. The stirrup, the spacing is at 125. So So we have three Y25 for this. So any of the concrete member you click, the system will bring out the design for that concrete member. To look at the design for this particular one, have 350 by 450. So this is the load for this particular side. So this is our system design for a reinforced concrete structure that has been designed together as a frame. So then in our next class, we're going to be looking at how to design using interactive steel design. Thank you for joining us. For our next class, we design using interactive steel design.